All right, moving on to number 4. So first, here's a trick that could come up. 3t minus 2 over t plus 1. So this is the idea that maybe you might have to do some polynomial long division. If there is some, it won't be hard, but you might have to do something. And this is the idea that this isn't a partial fraction problem on its own, because the degree of the numerator is less than the degree of the denominator. So the way we fix that is we say, okay, take 3t minus 2, you divide that by t plus 1. How many t's do you need to make t plus 1 go into 3t minus 2? So you definitely need 3. Multiply by 3, that gives you minus 3t plus 1. Or in other words, minus 3t minus 3. So I'm going to X this out because we're done with it. And so these always need to cancel. And you're left with minus 5. So what did what we just do say? We said 3t minus 2 over t plus 1, that's equal to 3 minus 5 over t plus 1. So then the integral of 3t minus 2 over t plus 1 is equal to the integral of 3 minus 5 over t plus 1 dt equals integral, or not integral, integral of 3 is 3t minus 5, integral of t plus 1, again technically a u substitution, but this is natural log of t plus 1, and then plus c. So that gets those partial fraction ideas warmed up, but wasn't really a partial fraction, it was just long division. But you might have to do something like that to get to the fraction. So now let's look at this guy. So 3x minus 5x squared over 3x minus 1 times x minus 1 squared. Okay, so what do we do here? Integral. We say that this is the integral of a over 3x minus 1. So let me use blue. So the blue comes from this part of the factor denominator. And then we're going to say plus b over x minus 1 plus c over x minus 1 squared. And that's because we have this repeated factor of x minus 1. So when you have a repeated factor, it needs to be like this. So let's go ahead and solve that. So I'm just going to write this out one more time. X minus 1 squared, a over 3x minus 1 plus b over x minus 1 plus c over x minus 1 squared. And now you multiply both sides by the denominator. So when you multiply a fraction by its denominator, you just get the numerator. Here I'm multiplying 3x, all this stuff, times this. So the 3x's would cancel, and I'm left with a x minus 1 squared. Plus, now for b, I lose one x minus 1, so I have 3x minus 1 times x minus 1. And then plus c, and it loses x minus 1 squared, and it keeps the 3x minus 1. Okay. So if we want, we can go ahead and find a, or we can make a system of equations, either one. So this one with the repeated root, I think it's easier just to find a, b, and c using a system. Give me a second. Excuse me. Okay. But if we wanted, we could actually find c pretty quickly by plugging in 1 into both sides. Because I would get 3 minus 5 is equal to a times 0 plus b times 0 is c. Actually, let me go ahead and show that because that's a good trick. So if x equals 1, plugging into both sides, I get 3 times 1 minus 5 times 1 minus 2 is a times plugging 1 gives 0, plus b times plugging in 1 gives 0, plus 3 times 1 is 3, minus 1 is 2, so 2c. So c is equal to minus 1. So what's the reason I do that? 3x minus 5 squared is equal to a times x minus 1 squared plus b times 3x minus 1x minus 1. And now I have minus 1 for c, so minus, I'll do these two steps at once, minus 3cx plus c, right? Because it's 3x minus 1, so multiply that by minus 1, you get minus 3x times c plus c. Sorry, we got rid of the c, that was the whole point. Plus 1, c was minus 1. So minus 1 times 3x is minus 3x, and then plus 1. And so now we have minus 5x squared plus 3x, plus 6x minus 1, adding this to both sides, is a, and now if I expand this x minus 1, it's x squared minus 2x plus 1, plus b, expand this, I get 3x squared, minus 3x minus x is minus 4x, and then plus 1. Okay. So minus 5x squared plus 6x minus 1 is equal to ax squared minus 2ax plus a plus 3bx squared minus 4bx plus b. Okay. So now we have the system of equations. So how do I pick these things out? I look at all the x squared stuff, and so I get minus 5 is equal to a plus 3b. That's from the stuff in green. The stuff in light blue, I have 6x minus 2ax minus 4bx, so 6 is equal to minus 2a minus 4b. And then finally, let's do the next one in purple. Minus 1 is equal to a plus b. A plus b. So I have 3 equations and 2 unknowns, so I can pick any 2 that I want. And it looks like the easiest one would be take this one. If this is true, then minus 2 is equal to 2a plus 2b, multiply both sides by 2. 6 is equal to minus 2a minus 4b, add those together. 4 is equal to minus 2b, or b is equal to minus 2. Now look at this equation. Minus 1 equals a plus b, but b is actually minus 2, so a minus 2, or a is equal to 1. So we've done our partial fraction decomposition. So it's a, b, c was minus 1. So I might have to go back and forth a little bit. I have a over 3x minus 1. So we have integral a was 1 over 3x minus 1 dx. B was minus 2 over x minus 1. So minus 2, or let me write it like this, plus integral minus 2 over x minus 1, and then plus c was minus 1, so integral minus 1 over x minus 1 squared, and then dx's. So these two are easy. You have to be a little bit careful here. You let u equal 3x minus 1. Du is equal to 3x dx. You only have one of them, so you get a 1/3 term. But after you do that, this looks like natural log. So 1/3 integral 1 over u du plus minus 2. This one I'm comfortable just showing that it's natural log x minus 1. Nothing too crazy there. And now here on the left, I've used u, so let me call this v, bx minus 1. Then this is really minus integral dv would be dx. So minus, I took the minus out, I have 1 over v squared dv. And so I get 1/3 natural log of u minus 2 natural log x minus 1 minus, I do the integral, so this is v to the minus 2, so I get v to the minus 1. And then what do I need to put here? It needs to be a minus 1. And so finally you end up at 1/3 natural log 3x minus 1 minus 2 natural log x minus 1 plus v was x minus 1, so I just get 1 over x minus 1 and then plus c. And that is our partial fraction problem.